Now I'm going to demo Cello Ansible Agent and stand up a 3-node fabric network against AWS. You can show that I have already logged in from terminal to Ubuntu machine. Actually, that's the Ubuntu machine. I'm running on VirtualBox. Here is one machine running. I don't have any other machines running, only this one. I already logged into this. So to provision the VMs, eventually stand up the fabric network, just need to run one command. Okay, before I actually start running this program, I want to show you actually the current AWS environment I have. You can see that I don't have any instance running, so it's all empty. All right, so I'm gonna go back to the terminal and start the program. So this command actually starts the all playbooks developed for AWS environment. And those warnings is because the deprecation of the command we use in a playbook. So you can safely ignore that for now. When we moving forward, we probably will replace use the not deprecated command. So you wouldn't see those warnings. Yeah, but for now, those warnings are just harmless. Okay, you can see those playbook will start by logging to AWS, trying to create the keys, create a security group, and now basically trying to set up the virtual host to provision machines in parallel. You can see we're trying to create those virtual machines. Okay, after a while, we should be able to see that those virtual machines already created on AWS from the AWS console. Okay, so here it says waiting until the server are up and running. So let's switch back to AWS management console. If we hit refresh, we should see here we go. We should see 3 nodes actually already provisioned. They're running. Okay, so this is the very first step. Once the server up running, we'll continue to step 2 and step 3. So we can wait while we wait for the whole process to finish. Let me show you how actually we configure Cello Ansible Agent to lay out the fabric network we wanted. Okay, so here is the root directory of Hyperledger Cello Ansible Agent. You can see from the path. And there's a directory called averse. This actually is a directory hold all the sample configuration files for Ansible Agent. You can see we have file called AWS Azure, here OS for OpenStack, and the VB for VirtualBox. Okay, so Agent actually use 2 set of configuration files. Those files with the cloud name and the files like BC first, BC second, and VB first. Those are for like blockchain first, blockchain second. All those files are example configuration files. You're supposed to create or at least change some of those files for your own need. So let's go into one of those files actually we're using. This is AWS for the demo. So this is the file we use to deal with different clouds. And we use here the name as AWS. So this is for AWS. You can imagine for OpenStack or Azure will be a little bit different, but the format is the same. So the first section basically is the authentication section. This you have to specify for AWS Cloud. You have to give username, which is your AWS Access Key ID, and here is a password. You can choose to put your password here, or you can set your AWS secret key as an environment variable. Okay, if you want to set as an environment variable, you don't have to put it right here. You just need to, at the command line, do a export AWS secret key equals to whatever the key you have. Okay, so the code is just developed like this. You can either put here or say, hey, I don't want to put here, worry about, I don't want to expose my password. So this is all the information you need from your AWS account. Now here, the second section actually indicate how many nodes what machines you want to create, which region, and what you want the secure group to be called. Target OS in our case should be always Ubuntu. And the image ID, I choose the image ID. This is very generic, sort of like an official Ubuntu. 1604 AWS image. Then you can specify how big or small you want your each virtual machine to be. You have to specify the SSH user name. You can also specify if you want to validate certificates, all that kind of stuff. Okay, so this is quite important, but you only need to do this once. And then you have to specify a public key and a private key when you create those virtual machines, because Ansible controller actually use SSH to access those virtual machines. So you want to specify a public key file and a private key file. So the playbook actually will create a key pair, which I will show you now here. See, in this configuration file, we said we want to call the security key to be fabric right here. So now the playbook actually create that right here. All right, so this is your key, and this SS public key actually will be injected into your virtual machines. So when Ansible controller, which running any machine you choose, trying to access the virtual machines, so this is the pair of the keys will be used. Okay, so you should have no problems to access your provisioned virtual machines on AWS. Okay, so those are very important things. If you're running this thing against AWS in Southeast region, chances are you don't have to change any of those configurations from the example file. You probably just need to change your access key ID and set up your password. But you do need to make sure that you have this public key and private key generated before you actually run the script. Okay. Then the next section shows that how you want to create your overlay network. Okay, So this is a little bit more advanced topic. We just don't have time to explain all the details here, but the gist here is that we have to specify how the overlay network segment should be, what's the subnet length, the protocols you're supposed to use, and in many cases you do not need to change anything from line 33 to line 42. Just use this, it will work against your AWS cloud account. So here is the service IP range and DNS service IP. When you use Kubernetes, Kubernetes requires you specify service IP range and the DNS service IPs. So this is important when you want all your pods and talk to each other, use the names instead of the IP addresses. So those things are quite important. And line 49 shows actually if you want your virtual machines to be dedicated with a specific IP address you have already pre-allocated, you can just list it right there. Now the virtual machines you create will pick up the IP address here and assign to the virtual machines. Okay, so this is done for you by the playbook. You don't have to do anything. But if you don't have pre-allocated IPs, leave it blank as the comment says. Okay, you have also some flexibility in terms of how you're gonna name your virtual machines. So here the default name prefix for all the nodes you create is called a fabric. That's the reason why if I switch back to Amazon console, that's why you can see those virtual machines named the fabric, start with fabric, then 01, 02, 03. If you want to create more than 3 machines, here you can specify the stack size to be 4, 5, 7, 8, whatever number you prefer. Okay, so if you specify this number, change this number to let's say 5, you should have 5 virtual machines created for you automatically. In this demo, I simply just use the default value, which is 3. That's why those are 3 machines created or running. And rest of the section indicate how we want to lay out etcd. When we set up Kubernetes, actually etcd is required. So here we use the first 3 nodes to set up etcd cluster. Okay, so we also can specify on which machine we want to build fabric. Okay, Ansible agent can actually provide you the capability to build each of the binary or container images for fabric components. So here you can specify that fabric 01, the machine, as the builder to build the binaries of the fabric. Rest of the sections, normally you don't have to change anything at all because we mentioned that we set up overlay network for containers. So we use Flannel to do that. We need to get the Flannel binaries. So here's how you can specify where to download those packages. The reason why this is set up here as a configuration primarily is because in your production environment, you probably want to set up a repo locally that when you deploy your stuff onto different environment, you can actually change this value to a local URL that make all your deployment runs very fast. Same thing for etcd repository and Kubernetes repository. You can change all this to your local HTTP server, which have all those binaries or the packages available. Okay, you can even specify what Golang version you want. Just simply change the number right here. Okay, so rest of those configuration options are optional or for future use, in case you want to specify like a volume, how much storage you're supposed to have when you generate virtual machines on different cloud. So this is one of the two configuration files. Basically deal with cloud, how the virtual machines created, how your overlay network gets set up. You should not change the format of this file. You only need to change the values based on your own environment. Okay, this is the first file. I'm going to go back to this directory. I'm going to show you the second configuration file that is needed. So this file actually is also very simple. You have a get URL, which is to tell Playbook where to get the source code of Fabric. You can also specify the ref spec, which will indicate what level of the Fabric you want to use. Currently, this is set to 1.0.5. You can imagine that when Fabric release more versions, this will change. Also, you can fall back. They say, hey, I don't want a 1.0.5, I want a 1.0.4. So you will comment this out, uncomment this one. Then the source code, the playbook draw from the repository will be the level you want. Okay, what is really interesting here is the section start at line 13. This is how you specify your layout of your Fabric network. Again, we need to know the user to be the user ID we use to access those virtual machines. Here on line 19, you can specify what database you want to use for your peer database. Currently, two different databases are supported. You can choose GoLevelDB, that's the default, or you can say, hey, I want to use CouchDB. Okay, you can also specify if you want a TLS to be enabled or not. Okay, what is really important in this file is how you want to lay out your Fabric network. Remember, we said we want to create a 3 nodes, right? The stack size was 3. That means we have 3 nodes. The node will be named Fabric 01 to Fabric 03 because of this configuration file. Here it says the stack size to be 3. The name prefix is Fabric. Okay, so you want to use this as convention to configure your Fabric network. So each of these actually present a virtual machine, a node, right? You see that we have those names here. Now on each virtual machine, here is how to specify what should be running on that particular machine. So we have actually 5 lines. Each line's value actually is an array. You can see that. So we have CAS. This means the certificate server. And of course, Fabric has peers, orderers, and zookeepers in Kafka. Okay, so this means on this very first machine, right, or VM, we want to run one certificate server for organization named org A. Okay, if I look at the second server, Fabricator 2, just look at CAS, I want to run one certificate server for organization B. Same thing for the third node, but on third node I want to run two certificate servers. One is called CA first for organization named org C. One is called CA first for organization named org D. Okay, that's for the certificate servers. Now, same way for peers and orders. And for peers, a little bit different. And you have the @ sign in the middle, and you have anchor in front of that. This actually means what role this particular peer will play. So here basically says, I want to have one peer named peer first in organization A, which will act as an anchor node. Okay, now look at this one. Say I want the other peer also named peer first, but that peer is in organization B, and it will also serve as an anchor node. Okay, now if I move to the server 2 or the virtual machine 2, I can see that I want another peer called peer second in organization A, and this peer actually will act as a worker node. Okay, same way for another peer in organization B. You can see that for organization A, actually I have 3 peers. Organization A, peer first, organization A, peer second, organization A, peer third. Okay, same way I have 3 peers in organization B. All right, so you actually can change this according to your own need. You can choose to put all the peers on this node in organization A, all the peers in organization B on second node, and so on and so forth. It's completely up to you how you want to lay out your own fabric network. Orders, it's very easy. On machine number 1, we have 2 orders, and they're from different organizations though. One's org C, one's org D. Okay, so we have order first in org C, order first in org D. Okay, same way. Now Kafka and the Zookeeper should not belong to any organization. Therefore, they only have names. Okay, Zookeeper, we have Zookeeper first, Zookeeper second, and Zookeeper third. The reason why you want to spread the Zookeepers and Kafka on different node is that, let's say your node fabric number 202 goes down. Okay, then your Zookeeper and Kafka will continue work because you still have Zookeeper first and Zookeeper third, Kafka third, and Kafka first node running. All right, if you put all your Zookeeper containers or the node on one machine, if that machine goes down, your whole network go down. Okay, that's the reason you want to spread out those onto multiple servers, and that's also the way to lay out your fabric network. How many organizations you want to create, and how many peers, orders, or CAs you want to stand up. And this is totally up to you. If you have more nodes, you just have more of these sections. If you want have less node, you just remove some of this. Okay, so this is the second configuration file you have. Ansible agent will take these two files, will parse the configuration in each file, then create certificates and stand up all the containers or pods or services automatically for you. All you have to do is to make sure these files actually reflect what you wanted and is in the right format. For example, you wouldn't miss the comma or some other things that YAML file requires. Okay, now this actually, the playbook already finished. While we're talking about a lot of other things, you can see at the end of this Ansible playbook, we give a little message about when the playbook actually started, when it finished. Looks like this play actually took about 10 minutes, a little bit more than 10 minutes. Everything was successful and everything is working. So now let's see what happened. We use one node to access the Kubernetes dashboard. Here you can see that the IP address I use is one of the IP address that given to one of the machines that we created. Let me refresh this. You can see that I'm using Fabric01, this IP address, to access the Kubernetes dashboard, because when we run this playbook, Ansible agent always set up your Kubernetes dashboard on the very first node. Okay, so this is the very first node, IP address 34.232.76.89, and that's where we are going to use to access the Kubernetes dashboard. Okay, so here it shows that we have 3 nodes. Okay, this is as we expected. All right, they have been running 19 minutes. They have Kubernetes installed. And I can also show you the jobs. No, sorry, the pods actually created, right? We have this particular one terminated. I will explain to you why it is terminated and it's okay. Then we have other pods like peer second in organization A, peer third in organization B. They're all running correctly. Okay, then we should have services. And if I switch back to the pods, like this one, actually this is the container we created to generate the channels and deploy chain code on all the peers, and make sure that the peers join all the channels and can actually run a smart contract or run chain code. So here, if I look at the logs from the container, you can see that everything completed successfully. Okay, so there's no errors. So the channels have been created and all the peers join the channels. Okay, so this proves that everything's working, no problems. And from have no virtual machines at all in AWS account, to 3 nodes created, Fabric actually deployed, and all the pods created service are running successfully. Okay, so you can see that we create overlay network, all those containers, pods actually running on the overlay network IPs. Okay, so that's our demo. Now, if you want, after you set up this on AWS, you inspect everything is running and no problem, you can, if this is a developer environment, if you don't want it, it's very easy actually to destroy the entire network by simply going back to your playbook, change the mode from apply to destroy, same playbook, you'll say mode equal to destroy and run the command, and everything that you set up will be removed, include the key pairs that you created. So give like few seconds, then we can check from the AWS console if those machines will be gone. Here you can see that all the machines have been terminated. If I say change the instance state to be terminated, here all the machines actually already terminated, and the playbook runs with no issues whatsoever. Okay, so this is the demo. Hope you enjoyed it. Thank you.